All right, let's talk about something that runs pretty much everything we do online, the database. We're going to break it all down by thinking of it like building a house, starting from just a messy plot of land and ending up with a perfectly organized, secure home for all our data. Let's get into it. I mean, think about it for a second. Every single click you make, every photo you post, every online order, it all has to be stored somewhere, right? So how is it that the entire internet hasn't just collapsed into total, absolute chaos? Well, it all comes down to having a solid foundation and a really, really good plan.
So let's rewind a bit. Before we had the fancy systems we have now, the digital world was kind of a free-for-all. It was like a wild, messy piece of land with information just scattered everywhere. A total mess.
Seriously, just imagine trying to run your life with sticky notes all over the house. You'd have 3 different versions of your shopping list, your friend's phone number would be different in 5 different places, and you could never find anything. That's exactly what the old file systems were like. It was a nightmare of duplicated data, security holes, just a whole bunch of problems.
So to fix all that chaos, we called in the master builder, the database management system, or DBMS for short. This is the software that's in charge of the whole construction project. It doesn't just store stuff. It manages, organizes, and protects everything. It's the system that turns that messy plot of land into a proper, functional home.
Now, you would never, ever start building a house without a blueprint, right? Of course not. And it's the exact same principle with a database. You have to design the entire structure before you put a single piece of data inside. And in our world, that blueprint is called an entity relationship diagram, or an ER diagram. You can think of it as the floor plan for our data house. It shows us the entities. Those are the rooms. It shows us the attributes. Those are the features in each room, like the windows or the color of the paint. And it shows the relationships. Those are the hallways that connect all the rooms together.
Okay, let's make this real. Take a look at this. That rectangle in the middle that says student, that's our student room. And those ovals connected to it, name, age, roll number, that's the stuff that goes inside that room. It's a simple, clear plan for what kind of information belongs there. But wait a second. If our house has a ton of rooms that all look kind of similar, how do we find the exact one we need? Simple. You give every single room its own unique address. And in the world of databases, that unique address is absolutely essential.
This leads to a really cool idea. Not all rooms are created equal. You've got strong rooms, or entities. Think of a kitchen. It has its own clear purpose and can stand on its own. It's got its own address. And you have weak entities. This is like an ensuite bathroom. It doesn't really make sense by itself, right? It totally depends on being attached to a bedroom to have any meaning. Its identity is tied to that stronger room.
All right, so the blueprint is done. We know what our rooms look like. But a house is more than just walls and doors. To actually live in it without it becoming a total disaster, we need some house rules. We need a system for organization to keep everything clean and reliable.
And this image is a perfect way to think about those unique addresses we mentioned. Right in the center, you have the primary key. That's like the simple street address, 123 Main Street. It's the most direct way to find that one specific room. But then you have other types of keys. A super key might be something more descriptive, like the third house on the left with the blue door next to the big oak tree. It's more complex, but it still leads you to that one and only one house.
Speaking of organization, there's this massively important concept called normalization. Honestly, you can just think of it as the ultimate decluttering method for your data house. It's all about getting rid of duplicates, not having 3 copies of the same book in different rooms, and making sure every single piece of info is in the most logical spot possible.
And this isn't just a one-and-done kind of thing. Normalization has levels, or what we call normal forms. As you can see here, it's like you're leveling up your tidiness game. You start with the basics, and then you get progressively more organized and efficient until you're at a professional declutterer level. So let's break this down. First normal form is easy. 1 item per drawer. No stuffing multiple things into one slot. Then you move to second normal form. This just means everything in a room has to actually belong in that room. You wouldn't keep your garden tools in your bedroom, right? They go in the garage. And third normal form takes it one step further. Things in a room should relate to the room itself, not to some other random item in the room. Each step just makes the whole house more logical and efficient. Okay, the house is built, it's beautifully organized, time to move in. But living in a house means things are always changing. We're adding furniture, moving things around, getting rid of old stuff.
we need a way to do all of that without accidentally knocking down a wall.
And to do that safely, we use something called a transaction. A transaction is just a single, logical piece of work that is protected. The classic example is a bank transfer. When you move money from your savings to your checking account, that's one transaction. You can't have the money leave savings but never arrive in checking. It has to be all or nothing.
This diagram shows that incredible safety net in action. A transaction starts, it's active. If everything goes perfectly, it gets to the end and it's committed. Success, the change is permanent. But if anything goes wrong, the power cuts out, anything, it immediately fails, rolls back any partial changes, and ends up aborted. No harm done. The database is left exactly as it was. It's genius.
This whole system of trust is guaranteed by 4 rules that have a great acronym, ACID. Atomicity, it's all or nothing. Consistency, the house rules are never, ever broken. Isolation, 2 different people doing things at the same time won't mess each other up. And durability, once a change is committed, it's there for good. It survives anything.
So we have this amazing house. It's organized, it's secure, it's reliable, but how do we actually talk to it? How do we ask it to find something for us or to store something new? Well, you need to speak its language.
And that language is called SQL. The beautiful thing about SQL is that it's designed to be readable, almost like plain English. If you want to see everything that's in the customer's room, you literally say, select star, which just means everything, from customers. Simple as that.
Okay, but what if you don't want to see everything? What if you only want to find the customers from Mexico? Easy. You just add a condition. You still say select star from customers, but then you add where country equals Mexico. It's direct, it's logical, and it's incredibly powerful. But here is where SQL becomes magical. It lets you connect information from different rooms using something called a join. Let's say you have a customer's room and an orders room. With a join, you can ask to see a customer and all the orders they've ever made, all in one go. A left join is even cooler. It can show you all your customers and then list their orders next to them, which is a great way to see who hasn't bought anything from you yet.
And that's the whole journey. We went from a totally chaotic plot of land to building a solid, secure, and brilliantly organized structure. We used blueprints, we set up house rules for tidiness, and we learned how to talk to it. That, right there, is the invisible architecture that holds up our entire digital world.
And look, this isn't just some abstract theory. This is the fundamental engine that powers every app you use, every website you visit. It's everywhere. So the real question is, now that you understand the blueprint, what kind of amazing data house would you build?